enlarged seat spacing, wide aisle between the rows, state-of-the-art climate control and lighting, anti-aerophobic interior design, enlarged luggage rack, and multimedia package. This is how an MC-21 passenger aircraft looks, and specialists assess the composite materials, which constitute about 40% of the new liner and the most perfect wing in its class. What technologies are used to create the new plane? How many companies cooperate to assemble the MC-21? Why is it called the plane of the 21st century? After the 90s, the Russian aircraft industry manufactured only military novelties. Out of civil aircrafts, only the Sukhoi Superjet 100 is in mass production. About 100 of these airliners have been released. Foreign manufacturers are continuously upgrading their planes to reduce fuel consumption and increase comfort. But all this is based on airframes developed tens of years ago. In order to obtain a plane with perfect aerodynamics, it should be designed from scratch. This is the only way to improve one of the main parameters of civil aviation, fuel efficiency. This task was tackled by the Irkut Corporation, which incorporated the Yakovlev Design Bureau in early 2000s. The team has experience in designing successful passenger jets Yak-40 and Yak-42. These aircrafts were competitive on the global scale and were supplied to many countries. A full-scale development of the new plane named MC-21 started in 2008, supported by the Russian Ministry of Industry and Trade. In order to win its share in the market dominated by Boeing and Airbus, Irkut designers relied on technical superiority.
Now we had to take on the market, enter the market. We could not go to this market with an iron wing. We wouldn't win anything, not a single parameter. Therefore, it's technical solutions first of all.
The new MC-21, in basic version, should take up to 211 passengers. At the same time, the liner is wider than the closest competitors. That is more comfortable, but more economical due to improved wing aerodynamics. According to experts' calculations, fuel economy of MC-21 compared to the current generation of aircrafts will be 24%. At the same time, the competitors secure only 13 to 18% fuel economy even with the new engines. Economical, environmental friendly, quiet, comfortable, and of course reliable. These principles are integrated into the design of the new plane. In order to fulfill the specified tasks, the engineers deviated from the customary design models at the very beginning. The Yakovlev Engineering Center, the main subdivision of the Irkut Corporation, goes well without stacks of paper drawings and bulky models. The developers have at their disposal the most state-of-the-art computer program, or to be more exact, a single information environment. It is used to create a 3D digital model of the MC.
Growth is that we have headed for technologies at last. Those technologies we didn't have, and many still doubt we will do it.
The specialists can make their comments and corrections even online. At the same time, the system has maximum protection.
The rate of information exchange has increased, and time delays due to documentation completeness checks and release for production have been reduced. The plant process engineers begin working at a stage when part of the documents has been released, and part of it hasn't.
All information is transmitted via high-speed channels from Moscow directly to the plant in Irkutsk. Fighters, bombers, cargo aircraft, thousands of military and civil aircraft have left the shops of the Irkutsk aviation plant. In our days, the main products of the company are the Yak-130 trainer and the SM and MK modifications of the multi-purpose Su-30. In 2008, the Irkut Corporation has set another goal: to make an absolutely new civil aircraft. Yak-130, Su-30SM, the plant has been mainly into Army orders over the last years. However, this body part obviously does not belong to a fighter. It is the future MC-21, the first one to fly. This is a production shop. Most of the metal body parts are in-house production. The plant receives huge blanks, and specially purchased machinery literally saws a final part out of them. Such a machining center is capable of handling a blank up to 6 meters in size.
This is a canopy framework. That is, it's the front part of the plane where, here, windows are inserted, where the pilots sit. So it's the front part.
The initial blank weighed around 800 kilograms?
Yes, yes.
And the result?
Well, about 20 to 25.
Apart from new machinery and tools, the most state-of-the-art quality control methods are used for the production of the 21st century plane. What is interesting is that the plant didn't have to purchase new equipment for fluorescent control, although it hadn't been used in military production. Maria, as far as I understand, before, when the Irkut plant did only Army orders, such a control didn't exist. It appeared just recently.
Yes, it appeared recently. We made Airbus parts before, but now we make parts for the MC-21.
Parts are suspended to an overhead crane and lowered into a chamber where they are coated in a fluorescent compound. Then they are washed and thoroughly inspected in ultraviolet light. If there are microscopic cracks in the part, there will be no fluorescent substance left in it. All operations are done in parallel. The plant produces and checks components, and those that are ready are used to put together plane sections.
Here, our first plane has been fully produced on this line. You know, everyone has been through what he or she has been through. How do I put it? There is a word. We were maybe small-town guys, but we lagged a lot in terms of technology in the 90s. Well, we were on the verge in the 80s too. Now I can say we are abreast with the planet. We made a technology overhaul at all enterprises of the corporation that we are working on, the MC-21 in Russia.
By the way, one of the MC-21 bodies is not fated to rise in the air. In 2013, an aircraft body was brought to the Zhukovsky town near Moscow and handed over to the Central Aerodynamic Institute for tests. You are seeing unique footage now. A largest plane in the world, An-124 Ruslan, is delivering the body of the MC-21 plane from Irkutsk to Moscow. Its task is to prove that engineers made no mistakes when calculating the strength of the future liner. Ramp installation and unloading is done by the plane's engineers. It's almost a precision job. A small mistake and the 6-ton body may drop on the concrete. This, of course, can also be a strength test. But still, the test had better be trusted to professionals, the Tsagi engineers. The MC-21 compartment was manufactured in record 3 months' time, while the tests are planned to last for about a year. Tsagi deals with any Russian planes, from the Su-25 attack aircraft to a passenger liner. The MC-21 body has to prove that it can withstand the severest stresses. The aircraft wings are manufactured in Ulyanovsk. The Russian MC-21 liner has absorbed a multitude of innovative technologies. One of the main ones is the world's first almost completely composite wing, which consists of monolithic carbon fiber panels up to 18 meters long. It is produced at the Aerocomposite Ulyanovsk plant.
Among the pluses are the weight reduction. Then we have corrosion resistance of the material. That is, they are not so susceptible to corrosion as, say, metal, aluminum alloys, steel alloys. Here, so it has pluses.
At the moment, carbon fiber composite materials are actively used both by the military and civilian productions. They are used for small parts and for whole panels of the body, wings, and fins. However, while such companies as Boeing and Airbus produce composite structures from individual sections for the MC-21 project, it was decided to make wing panels from one-piece, long-length carbon fiber elements. This solution yields a more lightweight wing with higher aerodynamic properties than those of a metal one. The Ulyanovsk plant was built specifically for this end. The facility has mastered the most state-of-the-art technologies of composite production and quality control.
You know, I have been attending to this plant from scratch, in fact. My every visit to Ulyanovsk is my joy and pride.
Creation of wing parts begins when a machine lays a composite filament according to a preset program. The number of layers may reach 90.
From the moment, the most difficult thing at this stage is software. It is still being debugged and improved. As to the rest, it's a normal, undemanding machine. It works 3 shifts like a dog.
After the let-up is over, the part is sent to a furnace. A so-called infusion technology is utilized. It's this technology that facilitates making a very long wing. Vacuum and temperature ensure impregnation of the layers with adhesive and baking into a single mass.
With the infusion technology, we can impregnate it all in one passage. That is, we don't have to impregnate one part first, then glue on another one. So there are no glued parts. Yes, we get a one-piece structure. Then we can produce a part. We get an 18-meter-long wing, right? Which, in turn, improves the characteristics, aerodynamic characteristics of the aircraft.
The next stage is machining. A huge machine grinds the part, smoothing up the shape. It takes several hours. The output is an ideally balanced geometry. Before being sent to the assembly shop, each structural element is checked, and they look not only at the shape, but at the inner contents too. In fact, they ultrasound it.
U.S. tests allow us to determine where we have some inaccuracies. Yes, and what faults we have in our product. Well, at this stage, we don't have really serious faults. But in any case, we do stage-wise control.
Quality control is a huge concern. The Aerocomposite company has a laboratory in Moscow. It is there where the first part samples are produced after the infusion technology and are checked for strength. A part of a batch from the Ulyanovsk plant is sent there too. The state-of-the-art test benches break and ruin the parts, so that later one could say for sure what stresses they can endure. This shop at the Ulyanovsk plant assembles the plane wings from composite and metal components. More exactly, 2 individual panels, a separate station for each one. A wing assembled across Russia. Composite spars are made here in Ulyanovsk. Duralumin ribs arrive from Irkutsk and Belgorod. Mechanical parts will also come from other cities. And it's here at the Aerocomposite plant where the wing will be fully assembled and sent back to Irkutsk, where the right and the left wing panels will be joined with the body. Currently, the plant is fully ready for batch production. However, expansion capacities are integrated into the facility itself. As soon as there is a need to increase the number of planes, additional equipment and assembly stations will be purchased for Ulyanovsk. Meanwhile, the first wing has already been handed over to the Irkut Corporation and installed on the new MC-21 liner. Here, The shape of the future plane can already be seen. 2 sections have been assembled. Soon the third one will arrive, and the wing will be attached to it. So the first half of the body will be ready. The second one is being assembled separately, after which both halves will be taken to the final assembly shop, where the plane will finally be assembled in full. A separate assembly station has been made for each body section. Here, for example, the central part is being prepared. The wing panels are attached to it. Assembly precision is the main parameter. The tolerances are minimal. 6-meter-long components are aligned and joined with micron-size positioning.
The middle part of the body, which we assembled in the shortest possible time. We had big difficulties. Well, positioning this compartment. We used laser rulers and leveling to install these components.
One more section is being assembled in parallel to the central one. It is called F4. It is located immediately behind the wing in the plane. The part is special so that it is not installed on each plane. This section is optional in a plane. If it is present, we get an MC-21-300. That is a longer version. If it is not present, then it's a 21-200. But the first plane version will be specifically elongated. Now this section is being prepared for mounting. Both sections are ready for transportation to the half-body assembly station. In order to haul them, the plant purchased transporter robots. They are remote controlled and can move in any direction. The body parts are arranged in the required order. Exactly half of the plane is assembled here. And again, the engineer's headache: joint precision. High technologies come to help.
We perform instrumentation control using laser trackers, which give us numerical coordinates of the spatial location of our compartment.
Simultaneously with body and wing manufacturing, the onboard electronics are mounted on the plane. Several innovative solutions were implemented during designing of the MC-21. One of them is modular avionics. Units and instruments, as well as software, can be upgraded during the entire lifetime of the liner. Avionics is one of the most expensive and complex elements of a modern aircraft. It amounts to up to 15% of its cost. It is for the first time in the last 3 decades that domestic companies were entrusted with integration of electronics into a civil aircraft. For example, the software core was written by the MSU mathematicians, the Red Lab Laboratory. The main job was performed by the UAC Integration Center Company.
If we take the previous project, which was done in Russia, it's the Superjet. The main integrator of the package was the French company Thales, and the Sukhoi group did there a fragment of the mathematics, an essential one, but a fragment. And today, in this project, the choice of suppliers and integration of the entire package and development of the mathematics is done by us.
All technical information is displayed on the pilot's monitors. The flight safety directly depends on how fully and conveniently it is presented. Therefore, the Russian developers have integrated several useful novelties into the cockpit.
For the first time in the domestic aviation, we use high aspect ratio displays, which gives the pilot better situational awareness. One of the specifics of our aircraft is the availability of pilot electronic tablets right in the basic version. The tablets allow him to almost completely avoid using information on paper. We also offer our clients a windscreen indicator, an advanced and synthetic viewing as an option.
All the avionics intended for testing and debugging of the software is assembled on a single bench controlled from the control panel of a cockpit copy.
We can say it's, in a sense, an electronic copy of the plane. Yes, in terms of electronics specifically, yes. Because those systems that belong to the electronics, well, the gear system and others, they exist. Yes, in the form of a simulator here. And the biggest part of the electronics, it is the actual one. That is, the equipment installed on the plane.
The digital copy of the plane will exist during the entire service life of the MC-21. It is used to debug the software, to stimulate various flight modes, and to improve the operation of the entire airborne electronics. Numerous checks, simulations, tests, and improvements guarantee fail-safe system operation, pilot convenience, and of course the safety of the new liner. In order to increase its competitiveness, the Irkut Corporation has decided to install two types of engines on the aircraft, a Russian PD-14 and an American PW-1400G. The choice of the suitable motor is up to the client. The MC-21 will perform its first flight with the engines manufactured by the American company Pratt & Whitney already installed on the plane. At the moment, it is one of the most advanced aircraft engines in the world. In particular, it is used for Airbus A320 upgrade. The use of foreign-make motors solves two tasks: speeds up the start of the test and increases demand from foreign customers. In this context, the engine produced by a well-known Western company is regarded as an entry ticket to new markets. Besides that, the PW-1400G facilitates testing of the new Russian engine PD-14 on a plane which will already have been run on a foreign-make motor. In parallel, a Russian power unit for the MC-21 is being worked on in the city of Perm. An absolutely new PD-14 has been designed. The city's two facilities are working on it: the Perm engine plant, where batch production has been established, and the Aircraft Engines Company, the developer. It is the first engine in its power class created in Russia since the breakup of the USSR. Thanks to the MC project, the Perm factories are coming alive again.
The PD-14 engine is being created according to the modern paperless design technologies, which allows for reducing the creation time of such an engine and for increasing the production quality of this engine, making it more economical and more reliable.
The new PD-14 has already raised the plane in the air, although not the MC-21, but a flying testbed. Four Il-76 engines make it resistant to a possible failure or fault in one of them. Besides that, the plane has excellent weightlifting capacity, which means measuring instruments can be installed on it. And in case of the PD-14, also to strengthen a part of the wing. The test pilots had no mercy for the engine. The PD-14 was run in all possible modes. It was turned on and off during the flight. Over 1,000 possible parameters were considered.
The engineering test stage, I think, will be completed. Well, I think in September this year. After that, well, we will obviously write a report about the readiness of the engine for installation on the MC-21. And after that, the certification test stage will follow.
Big orders are expected for the PD-14, especially considering its all-purpose feature. Apart from the fact that the engine was made to fit different modifications of the MC-21, it will also suit other planes. And not only planes.
The gas generator of the PD-14 engine can be used to create a range of gas turbine units for the gas transportation industry, for the energy industry. These are land units. And as maybe a distant but quite realistic perspective, it's helicopter engines, marine engines, etc.
The PD-14 project targets to win over 10% of the market in 7 to 18 tons power class turbofan engines. The first batch of finished engines is expected at the Irkutsk aviation plant. There, they will be installed on a fully assembled MC-21 plane. Here it is, the first assembled MC-21 liner. It is yet to go through many tests. The first flight is waiting ahead. However, it is a completely ready aircraft of the future already. According to expert estimations, narrow-body liners constitute up to 78% of the world's fleet of passenger aircraft of over 100 seat capacities. Analysts are confident in 20 years, their number will double to exceed 24,000 crafts. This is exactly why the MC-21 should go for batch production in the nearest future. It can fulfill the goal set by the government to increase the share of Russian aircraft in the world up to 10% by 2025. An important phase in the life of the MC-21 project, wheeling out the first liner. It is presented to the public and to the first persons of the state. In this way, the Irkut Corporation demonstrates that the work is going according to schedule. The aircraft has been assembled and will be ready for the first flight in the nearest future. A lot of orders have already been placed for the MC-21. 175 future planes have been purchased by Russian aviation and leasing companies. The project is intended not only to create a competitive liner, but to revive the whole industry. Tens of facilities have received orders, and thousands of people have got a job. Plants purchase equipment, revive and upgrade production, and engines and designers have acquired priceless experience which will soon come useful for further developments. In the meantime, the Irkut Corporation is preparing for batch production of the liner of the future.